Hi, today we'll continue with the implementation fabrics. In this, we'll study about PLD, PAL, and CPLD. First, we'll see PLD. PLD is nothing but programmable logic devices. They are integrated circuits. They contain array of AND gates and another array of OR gates. There are three kinds of PLDs, which is based on the type of arrays which has programmable features. One is programmable read-only memory, next is programmable array logic, and the third one is programmable logic array. We'll study in our syllabus programmable array logic. The process of entering the information into these devices is known as programming. Basically, users can program these devices or ICs electrically in order to implement the Boolean functions based on the requirement. Here, the term programming refers to hardware programming but not software. It was introduced by MMI in 1970s, the first widely used PLDs. These are programmed by blowing fusible links in the circuit. It uses a special programming instrument to do this work. We have having some examples over here for this PLDs, PAL16L8 and PAL16R8. We are studying with respect to PAL16L8. It has 16 inputs and 8 active low outputs. And if you are seeing the other one, it has 16 inputs and 8 registered outputs. We'll start with PAL now. PAL is nothing but programmable array logic. It is a programmable logic device that has programmable AND gate and fixed OR gate. The advantage of PAL is that we can generate only the required product terms of Boolean function instead of gathering all the min terms by using programmable AND gate. You can see the block diagram of PAL here. It has n inputs and m outputs. We have two components here, programmable AND array and fixed OR array. Here the inputs of AND gates are programmable. That means each AND gate has both normal and complemented input of variables. So based on the requirement, we can program any of those inputs. We can generate only the required product terms by using these AND gates. Here the inputs of OR gates are not a programmable type. So the number of inputs to each OR gate will be of fixed type. Hence, apply those required product terms to each OR gate as input. Therefore, the outputs of PL will be in the form of SOP, sum of product form. I have taken an example here. I have given two functions and these two functions have two product terms. Hence, we have to go for 4 programmable AND gate and 2 fixed OR gate for producing those functions. I have taken the functions A is equal to xy plus xz dash and A is equal to xy dash plus yz dash. Here we can see we have 4 AND gate and 2 OR gate, and I already told you that AND gates are programmable and OR gates are non-programmable, and also I have discussed you about the inputs may be either a complemented one or a normal one, so depending on your requirement we can go for programming it, and hence we got the output as xy, xz dash, xy dash and yz dash, which is your required one. You can see here these are the required ones, so you got it already. So once you take A and B, we'll get those corresponding outputs. This is the internal structure of PAL16L8. I have already told you that if you are going for PAL68, you have requirement is you will get 16 inputs as well as 8 active low outputs. So this is the structure of PAL. You can see here inputs are there, outputs are there, IO are there. I'll just tell you what all components we are using here. The component has 10 pins that are inputs, 2 pins that are outputs and 6 pins that are both input and output. So you can see over here inputs are there, I is nothing but input, O is nothing but output, IO is nothing but input output. So as we are discussing here, 10 inputs, 2 outputs and 6 input output. This gives a total of 16 inputs and 8 outputs. Hence the name 16L8. The symbol at each input represents a gate, that is a combination of a buffer and an inverter. Thus, the vertical signal carries all the input signals and their negations. The area in the dashboard is a programmable AND array of the PL. You can see here a dashed area is there. You can see the inputs, you can see the outputs, you can see vertical lines, horizontal lines, all those things. Each horizontal signal in the array represents a p term of the inputs suggested by the AND gate symbol at the end of the line. In the unprogrammed state, there is a wire called a fusible link or fuse at each intersection of vertical and horizontal wire signal connecting those signal wires. The PAL component can be programmed by blowing some of the fuses to break their connections and leaving the other fuses intact. This is done by special programming instrument before the component is inserted into the final system. I already discussed you about the special programming instrument in the initial slides. We require some program instrument to do all these functions. PL components such as PL16L8 can be programmed to implement a variety of combinational functions. Other PL components also includes registers allowing us to implement simple sequential circuits. So initially we have seen the internal circuit of a PAL. Now we are seeing about the output circuit. You can see over here you have an AND array, then you have a flip-flop and a buffer. You can see output. The same thing we have shown over there in the initial stage. I have shown you the only the output structure over here. It consists of an array, the tri-state buffer as well as inverter and a flip-flop, which gives you the output. Now we'll move on to the generic array logic, which is called as GAL. These components provide output logic macro cells, which we'll call it as OLMC, that replaces the combination of OR gates, registers and tri-state drivers in PAL output circuits. In PAL output circuit, you have seen all those things. It can be replaced by OLMC. Each OLMC includes circuits elements together with programmable multiplexers, allowing the output functionality to be determined as a part of programming the component. You can see here I have shown you the internal circuit of a GAL, and we are discussing that we are removing the components like OR gate, registers, tri-state buffers, and we are replacing by OLMC. You can see here OLMC we have replaced. It uses EEPROM technology, and example which I have taken is GAL220V10. This is the output logic macro cell of the corresponding GAL. You can see here OLMC has P input terms from an AND array with the same organization as that of PAL component. The number of P terms range from 8 for some sections to 16 for other sections. The output of the OR gate connects to a D flip-flop that has clock, asynchronous reset and synchronous preset signals in common with other OLMC in the component. Next we'll move on to CPLDs. CPLD is nothing but complex programmable logic device. It is a programmable logic device with complexity between that of PALs and FPGAs and architectural features of both. The main building block of CPLD is a macro cell which contains logic implementing disjunctive normal form expressions and more specialized logic operations. A complex programmable logic device is a logic device with completely programmable and or arrays and macro cells. Macro cells are the main building blocks of a CPLD, which contain complex logic operations and logic for implementing disjunctive normal form of expressions. You can see I've already told you that it is a combination of everything. So cramming multiple PALs into an IC will give you a CPLD. It has programmable interconnection network. It uses flash RAM technology to store the configuration. And I have told you already it consists of AND gate or array. It has macro cells. You can see here MC. IO block is there. So all those things are embedded and hence we'll call it as CPLD. AND or arrays are completely reprogrammable and responsible for performing various logic functions. Macro cells can also be defined as functional blocks responsible for performing sequential or combinational logic. Each of the PAL structures consists of an AND array and a number of embedded macro cells. The macro cells contain OR gate, multiplexers and flip-flops, allowing choice among combinational or registered connections to other elements within the component with or without logical negation, choice of initialization for flip-flops and so on. So macro cells having so many functions. A large CPLD may contain the equivalent of tens of thousands of gates and hundreds of flip-flops, allowing for implementation of quite complex circuits. So these are about CPLD. So it is a complex one, complex programmable logic device. It has both AND as well as AND or arrays along with MC circuits. Okay, so now we'll move on to the next topic in the next video, FPGA. Until then, thank you.